Alright, so in this problem, I have 4 to the power of x plus 6 to the power of x is equal to 9 to the power of x. So to solve this, I'm going to divide both sides by 4 to the power of x. So I get 4 to the power of x over 4 to the power of x plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. Now, 4 to the power of x and 4 to the power of x cancel out, so I get 1 plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. And if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, 6 to the power of x over 4 to the power of x is going to equal 6 over 4 to the power of x. And 9 to the power of x over 4 to the power of x is going to equal 9 over 4 to the power of x. Now I can simplify these fractions. So 6 over 4 is equal to 3 over 2. And 9 over 4 I'm going to rewrite as 3 squared over 2 squared. And I can actually use this property again for 3 squared over 2 squared. So that's going to equal 3 over 2 squared to the power of x. And if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of n to the power of m. So this can equal 1 plus 3 over 2 to the power of x, which is equal to 3 over 2 to the power of x to the power of 2. Now I'm going to let 3 over 2 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y minus 1 on both sides, these 4 cancel out, and I get y squared minus y minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared minus 4ac. So negative 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. Now this is equal to positive 1 plus or minus square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So y is equal to 1 plus or minus the square root of 5 over 2. However, we're not done yet because we're not solving for y, we're solving for x. And remember how we let 3 over 2 to the power of x equal to y. So this gives me two equations. I have 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2, as well as 3 over 2 to the power of x is equal to 1 minus the square root of 5 over 2. Now to actually start, we can already cancel out one of these equations, which is the right-hand one, because 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it equal a negative number. So this equation wouldn't even work. So the only equation I have left is 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now this turns into x times log 3 over 2 is equal to log 1 plus the square root of 5 over 2. And now if I divide both sides by log 3 over 2, I get x is equal to log 1 plus the square root of 5 over 2 over log 3 over 2. Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to x to the power of 5. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, I'm going to rewrite my equation down here so I have a little more solving space. So my equation x to the power of 3 is equal to x to the power of 5. And what I'm first going to do is subtract x to the power of 5 on both sides. So these two cancel out. And I get x to the power of 3 minus x to the power of 5 is equal to 0. Now, from here, x to the power of 5 is the same thing as x to the power of 3 plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of 3 plus 2 is going to equal x to the power of 3 times x to the power of 2. And now I'm going to factor out x to the power of 3. So I get x to the power of 3 times 1 minus x squared. So now this gives me two equations. I get x to the power of 3 is equal to 0, and I get 1 minus x squared is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 0. The cube root of x to the power of 3 is x, and the cube root of 0 is 0. So x equals 0 is one solution. Now for 1 minus x squared equals 0, I'm going to rewrite this as negative x squared plus 1 is equal to 0. And now I'm going to multiply both sides by negative 1. So negative 1 times negative x squared plus 1 is equal to x squared minus 1. And 0 times negative 1 is 0. So I get x squared minus 1 equals 0. And 1 is the same thing as 1 squared. So I have x squared minus 1 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is equal to x plus 1 times x minus 1 is equal to 0, meaning I get two equations, x plus 1 equals 0 and x minus 1 equals 0. For x plus 1 equals 0, I get x equals negative 1. And for x minus 1 equals 0, I get x equals 1. So notice how we have three equations for this equation. Notice how we have three solutions for this equation.